Check, mic check, and we're live. Good afternoon, everybody. Welcome into another live stream. We're going to go ahead and take our questions for today. What is going on? How's everyone doing? Juan, good to see you. Let's get that poll up and active, ready to go. Hello. All right, so let's do only 15 minutes on the clock today. Chat, how are we doing today? Let's do 20 minutes. Let's do 10 minutes on the clock today. Chat, how are we doing? What should we focus on today? Ooh, circular motion. Should we focus on general chemistry, organic chemistry, physics, or calculus? Instinct, good to see you. I'm going to click start here, and only 10 minutes on the clock today. Juan's already ready to lock in. Make sure you vote on the poll is active now. Tap the top left-hand side of your screen so you can vote down below. And guys, as usual, we are going live every single week to answer your STEM questions. Instinct says circular motion. All right. I think I have some for those. Okay, first vote. Juan says organic chem. And we got one for circular motion. Guys, how's everyone doing this semester, this quarter? What are you taking this semester? If you've already been here before, welcome back. If you've never been here before, welcome in. This is Dr. Andrew. We're going to be doing another live stream today. Only 1 hour today, unfortunately. Actually, only 45 minutes today, unfortunately. But don't worry, we are going to do as many problems as we can. I think I'm going to go ahead and just jump right to circular motion. Now, as usual, if there's any questions, best bet for you to get help is to, number one, join the Discord, which is a totally free community where you can join by tapping the link in bio. Or number two, you can join up and ask your questions on the TikTok live stream schedule button at my website. That's engineeringminds.co. Once again, you can ask any questions you have for STEM. I do organic chemistry, mathematics, physics, and general chemistry. Okay, I think our first question, guys, is going to be circular motion. I'm going to jump right into it today because I don't have too much time, unfortunately. Now, I'm going to go ahead and share my screen here. So what in particular about circular motion would you like to go over? Guys, the poll is up on the top left-hand side of your screen, okay? You cannot comment and vote. You must tap the top left-hand side and vote in, okay? So make sure you vote in and tap the top left-hand side. Only got one vote for OChem. There we go. Got our second vote for physics. Okay, so Instinct. Yeah, Instinct, if you can get some questions for us, that would be sick. That would be sick. Okay, so Instinct, if you do you have any particular questions? Otherwise, should we just do like a general overview? Because otherwise I'll have to like kind of look here. So what questions? Let's start by just going over a general overview of circular motion. Okay. Fun to use kinematics. So it seems like we're getting a lot of for physics today. Awesome. Seems like we're getting a lot for physics today. I'm going to go ahead and just get started on the lesson because I don't have too much time today. So, but before I do, let me just bring this here. Okay. Guys, my laptop is super laggy today. Hold on, let me hide this for just a quick second. Okay, and get up my website. And we're going to get started right about now. So everyone that is in the chat, welcome into another live stream. My name is Dr. Andrew, PhD in chemical engineering. If you've been here before, comment the word new so that we know that you're new. Okay, so if you've never been to a Dr. Drew live stream, comment the word new so that we know that you're new. And if you've been here before, comment that lock emoji because you know we're about to lock in. So get off your bed, stop scrolling, and get out your notes because you're actually going to learn and follow along as we do these problems. You can answer the question of the day, which is what topic we should focus on today, by tapping the top left-hand side of your screen. And there's lots of goodies for you to grab at my link in bio. Go to www.engineeringminds.co where you can, number one, book tutoring. So if you need tutoring for STEM classes, I got you covered for Gen Chem, Math, OChem, and Physics. Just tap that book tutoring button, as well as explore the resources page where you can download tons of free resources. Next, we also have the free Discord community where you can join in, drop your questions, get your homework help, and meet other STEM lovers, future doctors, and engineers. Last but not least, you can tap this button that says live streams, and you can view the live stream schedule and drop your questions for the TikTok Q&A. Okay? All right, great. So let's get started. Once again, the poll is active, so tap the top left-hand side of your screen. Only 5 minutes on the clock today. At the moment, physics is cooking. And Orgo is second. So if you want OChem to win, make sure you invite your friends to the live. Share the live. Make sure that they vote in the next 5 minutes. Another vote for physics. Seems like today's going to be physics. Guys, I go live every single week, Monday through Thursday, right around this time. So mark your calendars and hit that follow. So the first request today is going to be circular motion. Okay? Circular motion. So I think what we're going to talk about is basically, okay, how do we come up with some of these equations? Okay, how do we come up with some of the equations here? So for instance, suppose I have a tether ball of a person, okay, here where a ball is on the tether here of a pole, okay? And chat, y'all ever play tetherball as a kid? That was definitely one of my favorites. And here's our ball. And so here's our pole. So I'm going to highlight this in a nice gray color. And this is a particular circular motion problem. So our pole here is going to be connected to our tether ball, which will be a handball. And we're going to say it has an initial velocity in the y direction. So this initial velocity, we're going to call this v naught, okay? And is going to have some components, okay? Which we can write in the I hat and J hat. Question for us, chat. If we do physics today, which physics is cooking, do we want to do calculus-based physics, non-calculus-based physics, or a combination so I can teach you the calculus but still make it easy to understand? Okay, and now I have this ball here is going to follow this circular path. All right. So let's go ahead and depict all the equations for circular motion. Okay. If the tether ball here is initially at some position x comma y, well, over time, it's going to follow the trajectory of this circular path. For instance, I can describe the position of the ball using our typical r vector here. So r vector will be our x and y components. And again, if there's any questions you have regarding physics, just drop a comment down below. All right, calculus, okay, dynamics. That's right, we're basically doing v squared over r. Ethan says do real physics, man. Do real physics. And great. So if this is our r vector here, then what we're gonna do is depict the change in position using the velocity vector here. And at some point, it's going to follow the trajectory on this curve, and which will reach another angle, which we're gonna call the cosine of that angle. So once again, we are gonna need some trigonometry here because I believe that physics is essentially the study of trigonometry. Guys, only 2 minutes left on the poll. Make sure you tap the top left-hand side of your screen if you want to vote. Okay. Now our V is now tangent to this circular path here. So our V is now going to be, I'm going to call that a V prime. Okay. So the velocity vector is always going to be tangent to the path. But which direction is the acceleration? Which direction is the acceleration here? So we're going to prove, we can essentially prove that the acceleration is always pointing where, chat? 5 votes for physics today. Only 1 minute left. Only 1 minute left today. We're going quick with it today. Make sure you tap the top left button and drop your answer below. All right. So Exactly. It's always going to be pointing towards the center here. Okay, it's always going to be pointing towards the center. And with that, we have our acceleration here. That acceleration is called centripetal acceleration. Centripetal acceleration is a fake vector whereby it is going to be defined as 1/2 times the speed squared, v squared over r. Okay, so that is going to be our first equation we have for centripetal acceleration. Now, because we know Newton's second law by now, chat, what is Newton's second law? Please let us know down below. This is called centripetal acceleration. Because we know Newton's second law, we also have another equation, which is what? I took all of statics, dynamics, thermodynamics was the easiest. Can you explain why centripetal acceleration is not a real force? That's a really great question. Well, centripetal acceleration is simply the force projected that always points towards the center. And it is not a real force because it is going to be called essentially it is a manifestation of the motion of the ball. Okay? So it is not a real force because simply it just, it manifested, it arrived, it arose simply by the momentum of the ball itself, not from an actual pulling force. Okay? And so that force is going to be given by F equals ma. This is from Newton's second law. Jojo, thank you for the follow. Carly, welcome in. There you go, William. F equals ma, exactly right. So now we're going to go ahead and Ethan, good job. F equals ma. Now we're going to go ahead and plug that in. Slay, absolutely. And we're going to go ahead and say mv squared over r is our second main equation. And this is going to be mv squared over r. Now, the beauty of this is because we have, this is our net force. This is going to be our net force. Well, what if this is in the presence of gravity? So we can still have our other equations from the previous chapters. Recall that force weights can be equal to mg. So that's going to be our gravitational constant. Okay, so that's going to be weight equals mg. And we also have Newton's law of gravitation, which is given by g m1 m2 over r squared. All right, chat, welcome into the chat, guys. It's been only about 13 minutes. We are just getting started here for today. We got 5 votes for physics today, so I think that's what we're going to focus on today. I have about 15 problems here that I would love to work on. The first topic we had here was circular motion. And we can either do practice problems or more concepts or equations. Just comment down below what topics you're focusing on, what has been causing you confusion. I would love to do some examples, whether it's kinematics, circular motion, Newton's laws, free body diagrams, or we can even do electricity and magnetism. Ain't statics just dynamics, but just stationary? Are you willing to do center of mass with calculus after this? Absolutely. Let's see if I recall the formula for center of mass. Let's see if I can derive it from scratch. Thank you, no, appreciate you. I did get a haircut. Ethan says dynamics. My PhD is in chemical engineering. Okay, so consider a scale. Let's consider a scale where we have a series of different weighted balls here, which we're gonna call M1, M2, etc. Okay. The next topic we're gonna cover is center of mass. Unless you guys want me to do problems, just comment problems. And so center of mass here, consider these different size balls here. And let's see, I might be slightly rusty, so let's see if I can derive it from scratch here. I'm gonna call this one mass 1, mass 2, mass 3, mass 4, and mass 5. Our goal is to determine the center of mass. Okay, our goal is to determine the center of mass here, which would effectively be At what location would the greatest weight would the average at what location along this line would the average of all these different mass particles be located? Ways, thank you for the rose. Akbar, thank you for the rose. Sid, I definitely do Orgo. I can send some problems, please do. Now, I'm going to define an equation which I'm going to call center of mass, which is effectively the average weight. Now, what is the formula for average, chat? Where is the formula for average? Let's see if anyone recalls the formula for average here. Using your intuition of mathematics, how do we define our intuition for the concept of average here? Average weight. Let's just say average mass to not confuse weight versus mass because there is a difference. Okay? So I want you to think about, well, I see that let me interchange mass 4 and mass 3. Okay? Let me interchange mass 3 and mass 4. Would you agree that because we have the biggest weighted balls on the left-hand side, the center of mass must lie to the left here? The center of mass must lie to the left here. So all I have to do is effectively calculate the position of each of these balls, okay, which I'm going to define as x1, m1, okay, x2, m2, x3, m3, x4, m4, and x5, m5. Okay, so TLB is correct. The sum of the total masses but divided by the total mass. Okay, almost there. Now, we also need to consider the total masses and their positions as well. So you're on the right track. Okay, so some people are suggesting the following formula. They're saying the average mass, which we're calling the center of mass, is effectively the sum of all the masses divided by the total mass. Okay, divided by the total mass. Now, the problem with this formula here is we're gonna just get 1. Okay, the sum of the masses is the total mass. Okay. Now I'm going to normalize it by essentially, what's really interesting is this is effectively the dot product. So the center of mass is effectively the total masses, okay, times those positions, okay? So namely, for example, let's give this some numbers. I'm going to say m1 equals 1. I'm going to say x1 equals 1. I'm going to say m2 equals 5. x2 equals 2, x3 equals 3, x4 equals 4, x5 equals 5, m3 looks like it's about 4, m4 looks like it's about 3, m5 looks like it's about 0.5. So if our formula is correct, we should get something less than 3, but more than 0. Okay? And we're going to say that they're off to the side here. So I'm going to plug in my formula here and say that the center of mass is the sum total of those positions times those masses. So namely, I have a 1 times, I have an x1, m1, plus x2, m2, plus x3, m3, plus x4, m4, plus x5, m5. Chat, are we still following along? Leslie, good to see you. Thank you for the heart me. Thank you for the heart me. Okay, and then we're going to add up the total masses here. Thank you, Leslie. Appreciate you. And that's our formula. All we have to do is plug those numbers in. Hopefully everyone can see that. And we're going to go ahead and compute that as follows. We have 1 times 1 plus 2 times 5. Okay, I'm just subbing those values in. Chat, we're going over physics today because physics cooked up the question of the day. So if you have some OChem questions, definitely shoot me a DM and sign up for my group course because today we are focusing on physics. I apologize to all the OChem folk, but physics was cooking up today. And basically just getting all these numbers here, 1 plus 2 plus 3 plus 4 plus 5. So someone down in the chat, go ahead and compute what is this total value. I did the formula for center of mass. That will give us the answer. It should be less than 3, but more than 1. And someone go ahead and compute that out for us. Can you do alkenes, alkynes? I would love to do addition reactions, chat, but we got to do physics today. Maybe we'll do OChem tomorrow. We're sticking with physics today. I apologize, chat. Today's going to be physics day. Tomorrow we might do OChem. Well, you guys cooked up the question of the day, which was physics. All right, so that's going to be center of mass. So what's the next question for physics we want to go over? Okay. A cheat sheet for alkene and alkynes. I have one. I can drop it in the Discord. Question for you, GC. Are you in the Discord? I can drop one for you. If you're in the Discord, I'll drop it in the hashtag chemistry channel. You know what? Let me do that right now. Okay. So that way I can pull this up and advertise while I'm dropping that in the Discord here. And if you want to join the Discord, it's 100% free. So just tap that link in bio. And I'm going to go ahead and pull up that cheat sheet, which will give you about 10 to 13 different reactions. And guys, if you're in the Discord, just tag me and I'll get to your problems because sometimes I forget. Lots of people are doing addition reactions, my clients included. They just started addition reactions. They just had their SN1, SN2 midterm, and now they're also starting addition reactions. Chat, we got to focus on physics, however. So if you need OChem tutoring, sign up for that link in bio. And what's the next physics topic we should focus on? Is it perhaps kinematics, practice problems, more Newton's laws, or what have you? JC, what's your Discord name, bro? JC, what's your Discord name? Leslie, thank you for the share. Appreciate you. How are you doing? Are you doing all right in Gen Chem? Okay. So here's going to be that review of reactions that I'm going to tag you if you just let me know your Discord name. So I'm going to send this over here. Okay, and so I'm going to drop this in now, and let's just switch back to physics next. Conical pendulum. Conical pendulum. I don't think I've solved that before. Conical pendulum. I'm gonna write it out. But I won't solve it because I am curious about it. I'm gonna write it out, but I haven't solved it before, so I won't solve it live. Okay? But I'm gonna write it out and I will look into it because that sounds really fascinating. So that's gonna be the next question. Is gonna be conical pendulum. But you're gonna have to help me out here because I haven't seen that problem before. So exactly what does that mean? Okay, LeBron, there you go. Thank you, appreciate you. There you go. All right, so check that out. I think that's going to be everything you need, bro, for your addition reactions. Okay, so let's raise this one more time. Conical pendulum. Okay, I just responded to you. So, what is a conical pendulum? What is a conical pendulum? Again, I'm not going to solve it today, but I will take a look at it because it does sound pretty intriguing. So, well, a pendulum is like this. Okay, so we can solve the pendulum problem. We do need some calculus, and we could use code to solve this. Okay, but it is not impossible to solve. But so this is a pendulum. But what exactly is a conical pendulum, chat? Please let me know. I'm assuming we're going to have, well, is it in the shape of a cone? They teach it in Physics 1. Why haven't I solved this before then? Can you add me for the addition reactions? I'll add you later, Juan. But I just dropped it in there. Oh, you dropped it in the Discord? Oh, thank you. All right, I'll check that out right now. They teach it in Physics 1. Why am I not recalling this? What is a conical pendulum? Thank you, Leslie. You're the GOAT. Guys, make sure you tap the screen as Leslie indicated. Super appreciate you. Okay, so is it just a pendulum? I think it is a pendulum. I think we're thinking of the same thing. Okay, cool. We're thinking of the same thing here. Got it. Awesome. So here we have a pendulum, chat. Let's see if I can solve this. Okay. This one I will solve. This one I will solve it because this is solvable for sure. Okay, I was a little confused about the conical terminology. A pendulum is a mass on a... Now, are we going to include tension? Are we going to include tension? Yeah, we should include tension. A pendulum is simply a it's a tether ball. Okay, and it's going to swing back and forth just like that. Okay, if I'm not mistaken, this one should not involve... This one could involve calculus. So the reason it's difficult is because we're going to have calculus unless we make some assumptions here. So I may or may not solve everything from scratch today, but let's see how far we can get. When the mass swings in a circle instead of a straight line. Yes, exactly. Okay, perfect. We have the same system here. So here's our system. Step one, we got to do the free body diagram. So I'm going to go ahead and zoom in on this pendulum and drop in my... First things first, we have gravity. And we have gravity here is pointing down. Okay. And we only have, that's going to be gravity, which is given by the vector negative mg in the y-hat direction. All right, and then we're going to go ahead and draw our tension force, which is pointing in the direction of that string, just like that. And that is our tension force, just like that. And great, we have this angle cosine theta. This is all we need. All we need is the angle and the mass. And let's see if we can get the tension here. The tension might be required as well. All right, so we're going to go ahead and apply Newton's second law. Let's see how far we can get before I start getting a little bit confused, because there's been some time since I've derived this from scratch. And we're going to apply Newton's second law, which is F equals ma. Now, the first things first is we do have circular motion here. So we got to convert this into our angular force here. Okay, before we worry about the right hand side, let's focus on the left hand side here. All I'm going to do is do the sum of all forces here, okay, is equal to gravity plus tension. And great. So our gravity vector is well defined over here. Let's go ahead and define our tension vector. So our tension vector is going to be decomposed into our components here. And meanwhile, I'm thinking about the right-hand side. I'm kind of like, what are we going to do about the right-hand side? Don't quite remember at the moment. Let's see if it comes to me. I'm going to draw a cosine here, an angle rather here. So the x component is going to be, let's see. Whoops, hold on a second. That is not the right angle. Let's be careful here. I think it should be right. If this is our angle, then, okay, if this is our angle theta, we've got to do similar triangles here. I'm going to do a side note. Here because if this is our angle theta, then I have another angle like that. So this will be theta here, which means that this will be theta. So that is not theta, chat. This is our theta up on top here. Okay, so I almost messed that up, but I caught myself just in time. The upper part, the y-axis here is actually going to be a cosine term. Okay. We're going to neglect friction here because it is in just air. We're going to have tension. We're going to neglect friction though. Yeah, let's say that theta is less than 15. Let's say that that's a really good assumption. Let's say that theta is less than 15. And if we have the adjacent side is actually going to be the cosine. So our tension vector is actually going to be t times sine of theta. That's pretty tricky. And that's going to be in the x-hat direction. Do you guys like unit vectors, or do you like x hat and y hat, or do you guys like I hat and j hat? I haven't checked the chat in a couple minutes now, so if I miss your question, I'm not ignoring you. I'm just kind of locked in. And this is going to be t cosine of theta here. All right. So great, we're off to a good start. And I'm going to go ahead and decompose the vectors. I'm not going to worry about my right-hand side quite yet, because I'm a little bit concerned about the right-hand side. I'm going to go ahead and do a vertical balance first. I'm going to do a y component here and decompose my components here on the vertical side. So my vertical is an mg going down. So I'm going to say a positive is our positive y. That's a t cosine of theta is positive. So I'm going to say positive t cosine of theta minus mg is equal to my m times my acceleration in the y direction. Meanwhile, let's just do a quick side note. My acceleration, if I'm not mistaken, it should be v squared over r, because that's precisely centripetal motion. So it should be the speed. So that's my equation number 1. I'm going to call this one equation number 2 because it's going to be the y component. Now let's break it up into the x components. Okay. And I think I'm still doing good here. If I get stuck, I'm going to go back to the chat. And let's see how we're doing. Okay. And x component is going to be my, well, I simply only have one component in the x direction. And that seems like at the moment it's going left here. So I'm going to call that a negative let's see. That's going to be a t sine of theta, because that's my x component, is equal to, well, that's going to be centripetal acceleration as well. All right. So I think let's take a pause here. And number 1, to the person who asked this, first question, is this helpful so far? Are you following along? Are you seeing what I'm doing here? I'm applying Newton's second law for the pendulum. Second question, we got to solve this. So let's see how far we can get here. Integrate secant squared out of secant cubed. That sounds fun. The bob moves in a horizontal circle, causing the friction and the bob to travel the surface of a cone. Oh, interesting. That one I'm going to screenshot that one and drop that one in physics, because that one sounds pretty fun. Wouldn't v equals 0 at the top? I'm going to screenshot that one. That one sounds really fun. The bob moves in a circular. Okay, let's see that. Okay, I also see Alex's question. Ooh, yeah, that's perfect. Okay, I see Alex's question. We're going to do that one next. All right, v squared over r, v equals 0 at the top. V would not be 0 at the top. Thank God I changed my major. Isn't this easier with energy? It probably is. It probably is easier with energy. Yeah. Okay, appreciate you. No, thank you guys. No, thank you. All right, so I think we're all up to speed here. It probably is easier with energy, but I chose to do it with forces. All right, so what can we do here? Well, we essentially got to solve for tension. We effectively have to solve for tension. And my first, okay, this is where I'm starting to forget, chat. I'm starting to forget. I noticed that my tension is pulling inwards. So do I want to say, ooh, I don't think so. Part of me wants to say that the tension is equal to the centripetal acceleration, but I don't think that's correct. That doesn't feel right. I don't think I'm going to do that. I think I'm going to replace everything with v squared over r for my acceleration. And I'm going to say negative t sine of theta is equal to the mass of the ball times my speed of the ball in the x direction squared over r. Similarly, on the right-hand side, and that's going to be equal to mv squared in the y direction over r. Okay, we do have the radius of that, so that's good. And let's see, we should have the speed is changing. And wouldn't it be equal to 0 at the top? Oh, that's what everyone's saying, at the top over here. So by the way, one thing we can do is small angle approximation, which I'm trying to figure out when we do that. So if we go to the top, then everyone is saying that the speed here will be 0. Okay, so let's say it goes at the top. Then at the top, I thought you meant all the way at the top. Apologies. At the top, then my Vx and my Vy are 0, which means I can neglect those and I can cross those out. Ideally, I would love to prepare, best case scenario, guys, if you send me the questions beforehand and then I can prepare before the live streams, because now I'm kind of low-key winging it, which is not bad, but now I'm not 100% confident, because now I'm going to say that t cosine theta is equal to mg, and therefore my t is equal to mg over cosine theta. Okay? And I'm not 100% confident that's the correct answer here. You do when sine of x is less than 15 or 10. So if our theta is small angle over here, maybe over here, okay? See, I'm not a big fan of this. I'm gonna BRB chat. I'm gonna check my book. I'm gonna check if my book has the solution here. If I'm not confident, BRB. And I'm back, and ideally, let's see, we should be able to still derive it here. Anyway, let's see if we can. Let's see, hopefully I'm not getting roasted yet. Okay, so far I'm not getting roasted. Okay. Yes, I remember I solved it a couple years back. Okay, great. So we're gonna call this phi double dot. We gotta integrate. No, we can't say that. No, we can't do that. We gotta integrate this. This is basically phi double dot. All right, we gotta do this. We gotta do this in terms of cylindrical coordinates. Okay. So here's my equations, and we gotta integrate this. So if this is physics 1, we need some calculus here. So that's going to be our, let's see here, that's going to be our f r equals mg of cosine theta minus normal here. Let's see, where did I go here? This is going to be g over r. Okay, I'm going to erase a couple things, and then we're going to integrate. So that's my x and my y. I kind of want to rewrite it in terms of, not in terms of x and y, but rather in terms of r and theta. Okay, so let's try again using parametrization. So I'm going to do polar now, and I'm going to let x equal to r cosine of theta and y equal to r sine of theta, such that we can parameterize. Okay guys, we gotta do this quick because I'm running out of time here. And great, and so if I plug this back into Newton's second law, we're gonna decompose this into the r component and the phi component, the theta component. Effectively, we're going to have the force in the r direction is going to be m r times that derivative squared, okay? And the force in the theta direction is going to be mr times that acceleration, okay? So I'm going to call this theta. I'm going to call this, the acceleration is theta double dot, and then theta dot squared. Cool. Now, if I expand those, on the left-hand side, we're basically going to have same thing. We're going to basically say have our mg cosine theta, okay, mg cosine of theta minus the tension, mg cosine of theta minus the tension, and that's equal to the mr double dot. Yeah, I'm curious if we can solve this using Lagrangians. Yeah, or lasagna. Okay, and he said lasagna. That's supposed to be Lagrangian. That's funny. Someone said Lagrangians was they said LeBron James. They said LeBron James for the Lagrangian. You guys kill me sometimes. So that's gonna be r sine of theta equals that mr, and then theta double dot. Okay. Cool. So we're gonna integrate this bad boy. So here's where we're gonna use our sine or small angle approximation and say that sine is approximately equal to theta. This is the small angle approximation. So now we can simply integrate this is mg theta, which is mr. We can basically cancel out one of those m's and just kind of squeezing along here because now I have my reference book here. Negative g theta, negative g over r equals theta double dot. Okay, and that's going to be the solution. That's going to be times theta, and then the solution to that is going to be none other than a sine function, sine omega t plus b cosine omega t. And there we go. Okay, so that would be the solution to the pendulum. Guys, this is a pendulum problem. I only have 5 minutes left, unfortunately, so we did a quick physics session today. Do we have the length of the string? Ideally, yes. We should have the length of the string. The solution was eventually going to be the solution to that differential equation, which was a sine omega t plus b cosine omega t, where a and b are constants. Omega is the frequency. That is going to be how we effectively derive the solutions. Now, I attempted to do it using Newtonian mechanics, but there's actually 5 ways of doing this. This is just the first way. The next way would be to use energy. A third way would be to use Lagrangians. I believe a fourth way would be to use a Laplace transform. I think is possible here. I just do not know how that would be possible, but I know you can do Laplace transform here. So there's at least 4 or 5 different ways to arrive at the final expression. Thank you, Scooby. Thank you. Guys, I'm going to be on for just a few more minutes, guys. Anyone that is just joining in, we are wrapping up just a quick session today for physics. Okay. And yeah, we basically did some pendulum problem. We introduced the concept of center of mass. Okay. And I'm gonna go ahead and check the Discord real quick. I'm gonna set this up and then I gotta solve it tomorrow, chat, because unfortunately I ran out of time. Okay, so I'm just gonna set this up, which someone dropped this in the Discord here. We have a rod going up like this. Okay, and this is a rod of length m with length L with mass m, and this is the y-axis here, and a particle of equal mass m is moving along the axis with v naught. Okay, so that's our v naught vector, and it's moving to the right. At t equals 0, the particle strikes the end of the rod over here and sticks to it. Ooh, this is a dynamics problem. I'm not sure if I'm I'm not sure if this is within my scope, but we can try it out. Find position. We need to find r center of mass as a function of time. Ooh, and the velocity of the center of mass. Okay. Once we find this vector as a function of time, we can differentiate that and get that. And we do have the answer, so that's good. Okay, we do have the answer. So I'm going to take a look at that for Alex. Okay, I'm going to take a look at that. If I finish it by tomorrow, that's what we'll start off. But unfortunately, gonna end it right about now, guys. Once again, thanks a lot for joining. I will be posting this live stream tonight up on my YouTube channel. You can sign up for the Discord, link in bio. Go to engineeringminds.co. Sign up for tutoring. I got you for math, chem, physics, engineering. Leslie, thank you for the pumpkins. Happy Halloween, friends, and hope everyone's doing amazing. I think pretty much everyone here is in the Discord, but if you're not, please join. And if you haven't already, go ahead and introduce yourself there. And yeah, catch me tomorrow around the same time. We'll be back at 6 o'clock PST, 9 o'clock EST. And yeah, Nadia, join in. Introduce yourself. And yeah, guys, you can book tutoring, see the resources, and see my schedule. And yeah, let me know how the semester is going. Okay, I will catch y'all tomorrow, my friends. I'll post this video tonight. And have a great rest of your night, my friends. Peace out.